Composition of transformations. Translation as composition. A translation can be defined as the composition of a horizontal displacement followed by a vertical displacement or vice versa. Notation for translation as composition looks like this. Note the symbol circle, called bubble notation, is used for composition. A good way to interpret the bubble is to use the word after. So here we have an example where there was a translation -8, so 8 down, after we translated 6 to the left, -6, so that our image is now translated -6, -8. So 6 in the to the left, 8 down. The composition of transformations means that 2 or more transformations are performed in a prescribed order to map one figure onto another. The example shows a translation given by t, -5, -1, L maps onto L prime, followed by a reflection given by reflecting over the y equals x line L prime onto L double prime. This is a composition that is written like this. Note, t is listed second, but is performed first. A glide reflection is the composition of a translation followed by a reflection across a horizontal or vertical line in the plane. Notation for the composition would look like this, with the translation here, and then the reflection here, L onto L double prime. Note the symbol circle, called bubble notation, is used for composition. A good way to interpret the bubble is to use the word after. This example should be read, the pre-image is reflected across y equals 0 after it was translated 5 units to the right. So let's do that again. The pre-image is reflected across y equals 0 after it was translated 5 units to the right. Here's an example. Let the glide reflection shown be given by this format. What are the missing equation and values of h and k? Alright, so the pre-image is here. So first it was translated this way. How many units? Alright, so let's look at corresponding points. This point was moved to there. So that was 1, 2, 3, 4, 5, 6, 7, -7 units to the left, and then 3 units up. So here that would be -7, 3. And then what line was it reflected over? Well, this corresponding point and this corresponding point are both 2 units from the line x equals 0. So it's reflected across this line, x equals 0. Alright, so here's the solution. The pre-image was reflected across the line x equals 0 after it was translated 7 units to the left and 3 units up. Example B. Let the glide reflection shown be given by this format. What are the missing equation and values of h and k? Alright, so here we have a reflection after a translation. So what we're missing here is where the translation ended up. Because if this is the reflection, that means that the translation must have been here, right? Or I'll do this in red. It must have been here somewhere in order to be reflected like that. So here we have our shape like that. So first we translated here, and then we reflected across this line here. Alright, so to show this translation, we have a corresponding point here and here. This point moved 1, 2, 3, 4, 5 to the right and up 1. So this becomes 5 and 1. And then it was reflected over the line y equals 0 to end up down there. So we have that right there. So here, this is where the translation was, and then it was reflected. Example C. Let the glide reflection shown be given by this equation here. What are the missing equation and values of h and k? Alright, so once again we have our pre-image here in blue, and then it was translated and then reflected over this line here. So where did this triangle get translated to before it got reflected? Well, in order to reflect over this line, the triangle base must be here, so that this point would reflect onto this point would reflect onto this point. This point then would be on itself, reflect over itself since it's on the line of reflection, so it would look something like this. I'm not a very good drawer. Alright, so 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. This triangle actually goes up like that. Alright, so our triangle was translated to that position, and then it was reflected over the x-axis. So to get from here to there, we have some corresponding points. Let's use B and B prime here. We move to the left, 1, 2, 3, 4, 5, 6, so that's negative 6 for H. Then we moved down 2, so negative 2 for K. And then we reflected over the line y equals 0. And there we go. In red we see our translated triangle. So this is our triangle that's single prime, A prime, B prime, C prime. And then we have reflected over the x-axis. Therefore, the green triangle is then A double prime, B double prime, C double prime. Example D. Consider the transformation. All right, so we have a translation and then a reflection that will map triangle ABC onto triangle A double prime, B double prime, C double prime. So we're going to graph two triangles. The intermediate image, so after the translation, and then the final image after the reflection. All right, so first let's do the translation. So we're going to go 4 units to the right. So let's take A and find A prime. 1, 2, 3, 4. Then we move 2 units up. So A single prime is going to be right up there. C is going to move 1, 2, 3, 4, 1, 2. So C prime is here. And B, 1, 2, 1, 2, 3, 4. So B prime is here. So here's our intermediate image, like that. Then we're going to be reflecting the triangle over y equals 0. So y equals 0 is this line here. So now let's reflect this over the x-axis. So let's find C double prime. So 1, 2, 3 units to get to the line of reflection. So 3 units down. 1, 2, 3. This will be C double prime. We'll do the same for B. So 1, 2, 3. 1, 2, 3. B double prime. And then A is 9 units up. So we'll then go down to negative 9 and have A double prime. And then we'll connect the dots. And here is our final triangle. Let's look at the answer. Looks good. Click the Desmos icon to access a website that demonstrates glide reflections over the x-axis. Click the Desmos icon to access a website that demonstrates glide reflections over the y-axis.